I bet some of you thought I wasn't streaming today, but I am. But it's probably not gonna be a very long stream. Um, Sorry, late and short, but better than nothing. Am I right? Um, yeah, I just had a tutoring sesh, so I've been sitting in my chair for an hour. I don't really want to sit in my chair for another hour, to be honest. Um, but I don't want to. I don't want to not give you guys something. But better than nothing. Am I right? So yeah. So I'm here, and we're gonna talk about some math, potentially. Hello, Luna. And yeah, Luna, I've got your quiz open, so that's what we're starting with. I remembered. Uh, yeah, I'll just put Reddit in the other tab in case we go there afterwards. So I'm gonna do this quiz on live stream, trying to figure out which set theory terms are nonsense and which aren't. Um, yeah, let's do it. Let's do it. Hmm. Okay, let's get into it. Is an invaluable cardinal a real set theory thing? Hmm. Oh yeah, you're right. Maybe I should wait a few minutes. Maybe I should wait a few minutes to let people get in. Yeah. I'll wait. Especially, probably a lot of people thought I wasn't streaming today too, because normally I would have started like an hour ago. Um, yeah. Oh, Ooh, I've been reading about spectral sequences lately, so I wonder what people are saying here. Um, I've been looking at Alufi and Bot and 2, just to get a really hands-on working example. There's of course that really nice, what is it? It was like a 3 blue 1 brown Ravi Vakil crossover post or something with like the puzzle piece picture. Um, yeah. Yeah, as amazing as the Rising Sea is, actually, I don't know if the explanation of spectral sequences there really made it click for me. But I'm liking Luffy's approach. I kind of just want to work through some basic details there, um, and then maybe try and prove. I know you can use spectral sequences to prove like the snake lemma and the five lemma, which are not like that's not what makes them valuable at all. But I feel like doing those, and then there's also the like composition of derived functors. So I feel like those like three things I really want to go through and do myself, and then that'll help me understand. Also, the spectral sequence. I'm looking at Bottom 2 because I want to understand the proof using spectral sequences that check cohomology is sheaf check cohomology is DRAM. You like to think of spectral sequences as a kind of algorithm for computing sequential homotopy colimits. Interesting. I've always wondered if it generalizes to the other diagram shapes. Interesting. Yeah, I don't know about it in that way. One thing I really like those is a Luffy talks about. Maybe I could just pull up a Luffy. One interesting perspective that he shared on it was that you're basically computing the difference between pushing the grating inside and outside. So let me find exactly where he says that. Oh, thanks. Yeah, this mic was such a good investment. I don't even remember why exactly I bought it. My like roommate many years ago was selling it. Did I buy it for YouTube so I would have maybe I bought it for YouTube to have a better mic. It seems like it was like a crazy investment of the time. I was even more dirt poor then than I am now. And you know, it was not cheap. It was like $300 or something, but it was a good investment. Yeah, so I thought this was an interesting perspective. He talks about so T is like the total complex, and he says that the spectral sequence helps you determine the relationship between the homology of the graded, uh, the vertical grading of the total complex and the vertical grading of the homology of the total complex. And that's a really interesting way of putting it. Haven't totally internalized it. You got 9 out of 24 on the quiz. Okay, cool. So 9 is the number to beat. What happens when you take the Langlands dual of the Langlands dual? I will. Oh, you're the. Yes, that person did send a list of math streamers. Crap, I should have. I don't want to go open my email now on stream. Maybe I can open it. I do have my office laptop here. Yeah, but still, I'd want to like copy paste. I'll review it in another. I'll show the list in another stream or something. I haven't gone and like checked it out yet. I haven't gone and checked it out yet, but yeah. Okay, maybe I'll answer his question about the Langlands duel, and then I'll take the quiz. Probably there's enough people here. So let me just say, yeah. So I mean, well, okay, we got to be careful. What do you mean by the Langlands duel? Because once you're at the duel, I mean, there is no taking the like the L group of the L group doesn't really make sense because like the starting point, say, is a okay, if we're starting with say a reductive group over some field K, then you can form. I mean, there's really a whole family of like I don't know what the right word is. Root duals like G hat. So remember, this determines for you a root system, which then gives rise to a dual root system, and then over an algebraically closed field, there's a unique group up to isomorphism, G hat, with this root system, right? So that's what the G hat group is. So, for example, so if you start with G over K, you could literally plug in it, like this could be, say, the closure of K, but it could be any other field. Then you form like the G hat over F closure. Then you could then go back, right? Because you take this thing and then it turns out that, yeah, the double dual of a root system is isomorphic to the original root system. So then you could go back and like plug in K bar, and like that's what you'll get when you go back through this way and you plug in K bar. You'll just get the K bar points of your original group G. But the L group is more than that, right? So the L group, you take GK, you get your G hat over, whatever field you're happen to be working over. Like for me, normally it's GQP, and then this is like the complex dual. And then the L group is going to be, I don't know if I'm secretly assuming quasi-split here, but it's going to be like it's going to be a semi-direct product where you have the Galois group of the closure of K, so this is the K that you started with, and then you take the Galois group of that closure. Maybe you need separable, whatever. that acts on the root system, like the action the Galois group acts on here, which gives you an action on the root system, which gives you an action on the dual root system, which lifts to an action on this thing, which is what builds you this semi-direct product. But now, like, this is not a reductive algebraic group, as written. So how do you even, like, what would it mean to take the L group of this thing? I have no idea. I guess there's versions. I guess if this is quasi-split, I think you can take a semi-direct product to some finite extension. I guess it should be K. And then I think you can realize this as a reductive group because, like, topologically, it's just like some finite product of reductive groups. So, I mean, maybe, but you've already like beefed up to some algebraic closure and twisted by a Galois group. So I don't know what the sense would be in, like, taking the L group of this thing again. FYI, there are some questions which have excerpts from papers or books. You retyped them all because you didn't want to format to influence the answer. Okay, appreciated. One picture has a typo. Okay. Right. Okay. I think we're ready to start with the quiz. I think we're ready to start with the quiz. Let's go. Okay. Is an invaluable cardinal a real set theory thing? My gut tells me bullshit, nonsense, made up malarkey. Why is it called the dual if you can't do it twice? Well, you can do the G hat thing twice. I mean, there's kind of well, maybe I'll talk. I don't know, actually. So the short answer is I don't know. I mean, roughly, yeah. Okay, there's maybe more to say about it than just I don't know, but okay. Also, keep track of your score because it doesn't tell you. Oh, come on. Weak. I gotta think for myself. What is this? Reverse 1984? Okay, I say I haven't heard that term before, and invaluable, I don't know, doesn't make sense to me, so I'm going to say it's bullshit. Nice. I got one. Okay. The gambit lemma in set theory a real thing? Yes, that sounds real. 100%. 100%. That sounds real to me. Nice. 2 for 2. Let's go. I'm the king. Best to ever do it. Is an honestly good node? Ooh. Is an honestly good node a real set theory thing? That's tough. I kind of want to say yes, but I'm just like, I could imagine that just being like a random graph theory thing. Ooh. This is tough. Is an honestly good node a real set theory thing? I'm going to, if I get this wrong, then I'm happy to have gotten it wrong. Yeah, I should have. Yeah. The description is nice. I say yes. Okay, we're coming back. We've got recovery. We've got a bit of a recovery here. Whoa. The set in some is strongly in the codes of pi and G just in case the relation. This does kind of seem. This does kind of. I mean, this reminds me of the MLab page so much, but I'm like strongly in the codes. I'm like, that doesn't seem like. It's like too weird of a name to be made up. You know what I mean? It's too weird of a name. It can't be made up. But I don't know. It also really has some MLab vibes. God, this is tough. I feel like some of the first ones were just, I don't know, somehow like intuitively I knew. This is tough. God, I don't know. Yeah. I should have gone with my NLab thing. Yeah, a low jump cardinal. Yes, I say yes. Low jump cardinal exists. Oof, rough. We're losing it, chat. I may not be the best to ever do it. I may not be actually. Suppose this and this holds. Let that be Hansel? Honesel? I say yes. Ooh, brutal. I'm getting brutalized here. Okay. Is Minnie Mouse a real set theory thing? Can I give an intuitive explanation why coherent or quasi-coherent sheaves are like modules? Yes, after this quiz. I feel like some people model sheaves based on module. In fact, it's not even, oh, that was the typo. I see. Oh, it says honest, not a typo. I see. I can even do better than give you an intuition. I can give you a case where it literally is just modules. Good, Luna. I'm glad that this is entertaining for you. Minnie Mouse feels like that. I believe it's real. There's some part of me that feels like it's real. Like I feel maybe I've seen it before. Maybe I've heard this term before, or like I don't know. Wasn't there like a Mighty Mouse cartoon or something that like I don't know. Like I feel like someone who grew up in the 80s that would like or earlier, like, I don't know, came up with Minnie Mouse. Yes, I knew it. Somehow I felt that one, you know? I just felt it. That's 4. I'm at 50%. That's almost a passing grade. Is the smallest uncountable this, that, and the other the title of a real research paper? I don't know. I feel like from what I've seen, mathematicians don't have that much fun with their titles. Physicists have a lot of fun with their titles. We don't. We're boring. A mouse is a real thing in set theory. Okay. In a certain model of ZF. Interesting. But I don't know. I mean, I also don't know. I haven't read that many set theory papers. Actually, I mean, now that I think about it, Joel David Hampkins is definitely having a lot of fun with his papers and stuff. So, not confident, but yeah. Well, now I'm not sure. I'm gonna say no. Okay. Yeah, that one had me a little shook. Okay. In LR, the reliable cardinals are precisely the Suslin cardinals. The result should be stamped made in Los Angeles. The reader who cares can untangle some of the credits for it from what follows. That seems like an actual... I don't know. That kind of seems like a quirky thing a human would actually say. Yes. Yes, let's go. We're at 6. Um, okay. Suppose T sharp exists for every T and R. The following are equivalent. What the What is star choose star? I mean, I know that there's infinite combinatorics and like, whatever infinite Ramsey theory and stuff. So I guess that could be, but Jesus Christ. T sharp. I mean, I know that 0 sharp is a thing, right? 0 sharp is a cardinal. Spicy 0, as they call it, I'm sure. Yeah, why not? This could be real. What is remove all limits? What is remove all limits? Is that a set theory thing? Nice. Got it. Okay. Zongshu, I'm coming for you. I'm gonna break that score of 9 right open. Giving you trust issues towards set theorists, you should have them already. I jest, maybe. Okay, well we already know that mice are a thing. So mouse pairs could be a thing. The iteration map is elementary in the category mouse. Yeah, sure, why not? That could be a thing. Yeah, nice. Here we go. That's 8. Oh crap! What was my answer for the other? I think niceness was a thing. Wasn't I right about niceness? I think I was. We saw that in this. That is surprisingly small departure from nice scales is unimportant. Regretfully, niceness will become important in due time. That is a sentence. I feel like I want to screenshot this and put that on Twitter or something. Regretfully, niceness will become important in due time. That's perfect. So yeah, I'm gonna say that's real. Oh, ooh, I got tricked because of the niceness existing. Set theorists reveal in how silly and out there your math is. Yeah, to be honest, it's kind of drawing me into set theory. Exclusive cardinal seems real. That seems like a real thing. No. Boo. Oh, no. Oh, how do I go back? Oh. I somehow skipped one. How do I go back? Do I just lose that point forever? Wow, that's cheap. That's cheap. I don't like that. Boo. No, ethereal. I did try to click the 16. It didn't work. I don't think there's a quiz for every area because I think Luna made this quiz. So I fixed my mic issues. I didn't do anything. I literally have not done anything. Ethereal cardinals are bullshit. What? Oh. Tall cardinal bullshit. Oh my god. Brutal. Active baby mouse. Now I'm broken. Oh, the question is a completely unfoldable cardinal a real thing? Is a completely unfoldable cardinal? Yes. I say yes. Is it? 0 for 4. Ooh. Brutal. Active baby mouse? I feel like no, but now I'm not trusting myself, so... Nice. Okay, there we go. I made progress by not trusting myself. Gotta do that more often. Hey, wasn't I okay? There was something like XYZ. Wait, but the other one, oh, it is real? Oh, wait, so I get another one? So I'm at 10 now. Nice. I'm crushing. I'm crushing. See, Zongshu, I told you I would just crush, decimate. Now I'm the king. The king is back. Okay, here's the thing. The other axiom blah 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 with the V in front was real. So this makes me think I'm being tricked and that this one is false. But then again, yeah, am I being tricked or not? Yeah, you know what I'll do. You know what I'll do, Daysen, is if I do get Professor Hampkins on here, I'll definitely see if he'd be willing to take the quiz. Now I'm sketched out about this though because the other XYZ thing was real. Or was it false? I don't remember. Let's go. Let's go. That hurts. Oh no, I hit skip again. Damn it. What was the last one? Luna, can you tell me what the last one was? Because I accidentally hit skip again. I'm tempted to just hit the back button, but I don't know. That could destroy everything. Let M bar M be acceptable mu structures. Preserving map, non. Is a hyper remarkable cardinal a real thing? It is because I invented it yesterday. Excuse me. Ooh. Okay, we got two more here. Oh, speaking of hyper simple sets. Oh, a theorem on hyper simple sets. Yes, it's so ridiculous. I don't know. Let's go. Yes, let's go. 11. We got one last one. Oh, that's the one I skipped? No way. Hyper remarkable is a real thing? I made up that term yesterday. Hyper remarkable. Because we were talking about remarkable yesterday, and I said the word hyper remarkable. I was like, oh, call it hyper remarkable if it's remarkable and unremarkable. Sure, why not? It exists, I guess. Yes. My answer is yes. Does it exist? I'll think about. I'm thinking about this one. Will you give me the answer? Is mouse capturing? You made the quiz like 3 years ago. I see. Ooh, I should I create a quiz for my area? Yeah, but I don't know if there's as much like. I don't know if there's as much crazy nonsense terms. I don't know if it works as well for my area. On a bit of a delay, yeah. Oh, I wonder. I should plug in my laptop. Someone once told me I should do that during streams. 20-second delay for everyone. That's brutal. Is mouse capturing sometimes needs long games to sufficiently iterate? I say yes. Ooh. Okay, 11. I got 11. I got 11, so that's not bad. Nonsense. Yeah, I see. YouTube censored because cursing. Oh. Well, 11's not bad. Out of 24, it's a failing grade, but yeah. Well, everyone else should try it and tell me what you got. Still worse than a monkey. Yeah, I guess that's better. That's worse than just guessing. Well done. Well, let's see who can beat me. No lying. No lying. Not allowed to cheat. No lying. Let's go read. Let's get back to something easy like spectral sequences. Most people get between 8 and 12. Okay, so I'm on the higher end of average. Set theorists get up to 20. Oh, that's good. That is good. Spectral sequences often the only way to get useful information about cohomology you care about. Yeah, I do want to learn. Yeah, okay. Great, I agree. I do want to learn those. Now, where? Tell me how. These notes. I bet. Is this the puzzle piece notes? Probably is. Yeah, it's a puzzle piece notes. Yeah. I should revisit them, but I don't know. I feel like I also just like these notes are really nice and cool and awesome, but I also at this point I just need to do some technical exercises. I think that's it. Can I explain motivation for mass forms? Nope. I don't know the motivation. Oh, there was a question about quasi-coherent modules. Yes. Sorry. Are you still here, Nathaniel Jones? I hope you're still here. Let me talk about that. So here is the simple way. Why here's exactly why people think about it in that way. Nice. Okay. So consider quasi-coherent sheaves on the scheme spec A. Then taking global sections is a functor to A modules. Right? The global sections of a quasi-coherent sheaf on spec A gives you an A module, and not only does it give you an A module, it's an equivalence of categories. So quasi-coherent sheaves on spec A literally is the category of A modules. And now, I mean, what is a scheme? You've basically just glued together a whole bunch of spec A's, right? Is this Sarah Swan? No, Sarah Swan's different. Sarah Swan's a little different. Yeah, I think Sarah Swan's a little different. Well, I know the analytic Sarah Swan says something that like the category of projective C infinity modules. I don't know what the normal notation is, but projective C infinity modules on X is equivalent to the category of vector bundles, maybe finite dimensional or something. I don't know. Well, vector bundles normally are finite dimensional. Whatever. Something like this is true. Something like this is true. Vector bundles on X are equivalent to projective C infinity, and then I think Sarah Swan for algebraic varieties is more different. Well, no, it should basically be this, right? But maybe that's just co. Yeah, maybe that's just co is equivalent to. I don't know actually. Yeah, what does the algebraic Sarah-Swan theorem say? Let's go in lab. How's it hanging? How's it hanging? It's hanging, Paul. It's hanging. What does this say? The category of finitely generated projective R modules is equivalent to the category of algebraic vector bundles, which is QCO, right? Maybe it is just QCO. Maybe Sarah Swan is just the QCO thing. Right. Swan from 62, finitely generated projective modules. Or should this just be co? Is this just co? I don't know. My brain's too smooth. It's got some wrinkles in it. Not enough, apparently. If one drops a condition that sheaf of modules over the structure sheaf of ring space is locally free and allows instead to just be locally presentable, one arrives at the notion of quasi-coherent sheaves of modules. I see. What do we got going on here in chat? Is there a book that serves like an extension or part 2 of Atiyah McDonald, do you mean? Or you could see from the stuff you're explaining to Tate modules? I don't know where to go read about Tate modules. Should be mentioned that this equivalence is totally artificial. QCO sheaves are defined as sheaves which look like modules risky locally. Is that true? I mean, I don't know if I would exactly say it like that. I mean, yeah, I don't know. I don't know about that. It seems like there's more going on. I don't like, in my mind it's not so immediately obvious, but maybe I'm wrong. There's a classical construction attaching cusp forms to Hecke characters of imaginary quadratic fields with matching L function. Mass forms allow generalizing this to Hecke characters of real quadratic fields. And there's also some motivations from representation theory and Eisenstein series. Yeah. I guess you could realize that because you want like a theory of modular forms, and I guess for the in order to capture like the more general version of Eisenstein series, you need mass forms, right? Sarah Swan is specifically about projective modules corresponding to locally free QCO sheaves. Okay. Walls of text are appreciated. You're going to try to be a person and go outside? Hell yeah. Yeah, everyone should go do that. I should go do that right away. And actually, by go outside, I mean I'll walk outside briefly in my walk across campus to go to the gym. It's time. It's the start of a new mesocycle, so I'm feeling refreshed. I'm feeling ready to crush, but I am going to hold back because it's the beginning. Can I use thinking in terms of modules to get an idea about whether or not something like the skyscraper sheaf is, for example, coherent or torsion free? Can you use thinking about modules to do that? I mean, maybe because. Uh, hmm. I mean, I guess it depends on what you mean by thinking in terms of modules. Because, like, kind of always. I don't know, kind of always. Um, uh, yeah. Uh, hmm. Because, I mean, like, to prove that it's, like coherent or whatever, you would need to think about modules basically. I mean, what do you do? I mean, how could you prove it? Because, like, if you're coherent, that means you can find some open cover such that blah blah blah. Um, so take your open cover such that blah blah blah. I suppose. Um, QCO from schemes to cat is just the right con extension of. See, I have no idea what that means. I've never learned con extensions, even though I know that's what all concepts are. Um, I don't get it. Maybe one day when I'm a big boy. Should be possible with some finite properties of modules. Yeah. Yeah. Ultimately, I'm not sure. But I am going to go soon, I think. I think we're almost at the end. Oh, I forgot about Hatcher. I should go look at that. I forgot he had his partial chapter on exact sequences. Yeah, Botan 2. That's my bedtime reading right now. So I look at Botan 2. Weibel works out all the proofs carefully. Oh, interesting. I should probably go read that. But it's not in an explicit context. Yeah, I think I need more of that. McCleary. Really? Interesting. Brown's cohomology of groups. I have that. Maybe it's at home. Where is it? I have it. No, it's at home though. I think it's at home. Group cohomology of smaller dihedral groups. Okay, I'll keep that in mind. But where the hell do I go read it? Botan 2 can be terse at times, but it is nice. McCleary has a whole book about them. Maybe I should go read that. Yeah, blah blah blah. I need references. This looks like a good answer, but it's too long. Yeah. I need references. Chow 2006. Interesting. Yeah, I think I'll just go. I think. Well, I think so far I'm pretty happy with 6 out of 10 times Reddit recs are good. Maybe. It's so it's one thing that drives me nuts, and this doesn't just happen on Reddit. It happens in so many places in life, where like people give like a good answer, and then other people come in. And it'll be hours later, so it's like, did you not look at the other answers other people already gave, and just give the like shittiest answer imaginable? And it's like, why? Why did you bother cluttering up the space by typing this awful answer that means nothing? And I know I need to just chill out, but it drives me nuts. It absolutely drives me nuts. Okay, I gotta go, gang. It's I've been sitting in my office too long. It's time to go pretend to be a real person. What do I think about Griffiths Harris algebraic geometry? I think it's sitting over on my shelf right now, and it stares at me temptingly all the time. But I've never sat down and seriously read it. Um, well, like you said, you asked how I have time to do all the things that I do, and how I have the time is I've not opened Griffiths and Harris despite my temptations to. Memes of destruction. It's too bad you just popped in chat now because we're about to go. We're about to take off. So hopefully I'll catch you in the future. But for now, go prove some theorems.